Alright, so here's the formula for arc length. Arc length is simply the radius, r, times the central angle, theta. But where students mostly mess up is that they forget that theta must be an angle in radians, not degrees. So let's see an example. Say I have a circle whose diameter is 8 inches and central angle created is 240 degrees. Well, right off the bat, I can find my r because the diameter is twice as long as the radius, so my r value I'm going to plug in is simply 4. That's half of 8. But what am I going to do with this 240 degrees? Well, I'll need to convert it. If you haven't already, review my video on converting angles to degrees and radians, etc. But for now, just a quick crash course. I take my 240 degrees, multiply with this ratio, 1 pi is equal to 180 degrees. My degree bubble cancels out. I multiply it all out until I finally get 4/3 pi. 240 divided by 180, that's 4/3, and just slap on that pi at the end to get my angle in radians. Plug it all in, you should get something about 16.76 inches. That's the length of the outer edge that's produced when the angle is 240 degrees. One more example. Say I just give you the arc length and the radius, but I want to know the angle. Well, using a formula, right, you can just solve this algebraically. If 6 is my arc length and 5 is my radius, well, I just divide by 5 to get my angle by itself. So the angle, but remember in radians, is 6/5. So this angle produced is 6/5 radians, not degrees.